Use technology to solve each system. First thing we want to do is come up with the augmented matrix. So take out the variables. Like so. We're going to plug that augmented matrix into a website. So to find this website, you can go to my website, and from the math sites, find the one that says Gauss Jordan. So once you're there, it's going to ask you to create a matrix. So our matrix was a 3 by 4. Usually populates with numbers. So go ahead and clear those out and then type in your matrix. Use the tab key. Makes it go faster, I think. And then we hit solve. This thing's going to take us through the Gauss-Jordan process, and we don't really care about their process as much as the answer. We get to there, that's their reduced row echelon form of the matrix. And so that looks kind of weird, but you can see this row right here says 0 equals 0. And we can tell we have more variables than equations. That means this is going to be many solutions. So let's go ahead and write down this matrix. We did a reduced row echelon form and got this result. Now, the zeros don't really matter. You could leave them out if you wanted to. But that's pretty much what we got. Now, we know this is many solutions. We can see this is many solutions. But we're going to need to go a little bit farther than just saying many solutions. We're going to need to describe them. So normally we'd have an XYZ point, but we're going to have to use a parameter here. We're going to use Z as a parameter. And what you can see is when you look at the middle row, that middle row says Y minus 4/7 Z equals negative 6/7. Hopefully you can see that without writing the equation. That's what that row says. I would want to add that over and see that Y equals 4/7 Z minus 6/7. That's the Y coordinate. So if I'm writing my XYZ ordered triple, the Y coordinate there in terms of Z, in terms of my parameter, will be 4/7 Z minus 6/7. I'm going to do kind of the same thing for the X. I can see that top row says X plus 1/7 Z equals 12/7. And so if I subtract that over, I'm going to get 12/7, X equals 12/7 minus 1/7 Z. And that's your X coordinate, 12/7 minus 1/7 Z. That's pretty weird looking, but that's your form of your many solutions. If you want some examples, just start plugging stuff in. Pick a number for your parameter like 0, something easy. And if you plugged in 0, you're going to get negative 6/7 for the Y coordinate. If you plug in 0 over here for Z, you'd get 12/7. That's one possible solution of the many solutions. So yes, we knew it was many solutions, but now we know those many solutions have to have this pattern, this form. And here's an example. So let's look at this one. I believe this should say example 5, but whatever, I said example 6. Notice it's got 4 variables this time. So if we did our augmented matrix, make sure you put 4 variables in there. The second one is missing a Z. The third one is missing your W. So, make sure you put that in there. Can't draw a 0. augmented. So 1x, 2y, 3z, negative 1w equals 4. 2x, 3y, 0z, and 1w equals negative 3. 3x, 5y, 3z, 0w equals 1. Is that a 1? Yeah. So there's my augmented. I want to do an RREF, a reduced row echelon form. And so I'm going to put that in that same website. Notice this is a 3x5 this time. So when we go back to that website, we can say go back to step 1 because we need to change it to a 3x5. Clear out whatever numbers are in there and type in. I promise the numbers are under there. If you want to clear out that add, you can. Okay, so I typed them in there. That ad's blocking some of them, but they're there. And so again, you solve this and you see that 0 equals 0 at the bottom kind of hints that this is going to be many solutions. The top 2 rows are the ones that are important, though. So let's get those. The 0 rows don't really matter. They don't really do anything. Okay, you could write down zeros and you could write down another row of zeros if you want, but it doesn't really do anything. I'm just more concerned about the numbers. Again, I know this is many solutions. And I can tell because there's more variables than there are equations. So the weird thing that happens, if you think about Gauss-Jordan, what we want to happen is we want numbers along the main diagonal. So normally there's going to be a number here and there's going to be a number here. But since those two are missing, those two are going to be parameters. So if you think about your variables, you had x, y, z, and w. In this example, you're going to have 2 parameters, z and w. They go with the missing variables. So all I would do is take that middle equation, which says y plus 6z minus 3w equals 11, and isolate the y. I want y in terms of my 2 parameters. So subtract this over, add this over. You'd have y equals 11 plus 3w minus 6z. Doesn't really matter what order you're in. The top row says x minus 9z plus 5w equals negative 18. I'm going to do the same thing. Move those terms over to isolate x. We'd have x equals negative 18 plus 9z minus 5w. And so your answer is not an ordered pair or an ordered triple. It's actually an ordered quadruple, I guess. But your x term, negative 18 plus 9z minus 5w. Your y term is 11 plus 3w minus 6z. And then you have a parameter z and a parameter w. Now, the parameter, remember the parameter is just, that's where you can pick whatever you want. Okay, so if I had to pick an example, I think the easiest thing would be to just pick zeros here for z and w. If you picked zeros and plugged them in, you're going to get an 11 for the y term and a negative 18 for your x term. That's one possible solution. Negative 18 for x, 11 for y, 0 for z, and 0 for w. That's one of the many solutions.